Hi everyone, we're in the basement of Kevin's home. Kevin is a friend of mine and we're going to find out about this brand new system he just had installed. Kevin, what's going on?
Hey guys, I'm Kevin. I live here in Massachusetts. I'm a solar installer. And as David said, I just installed this battery system.
And whose company is this?
This is LionEnergy. They're out of Utah. And they just recently came out with this system to get into the residential and commercial market.
So we're going to run through all the details on the system. We'll take some covers off and look inside. I'm really excited because it's the first time that I've ever seen it. I haven't seen it yet. So we're going to see it for the first time together. But I'm going to let Kevin take over and I'll just be behind the camera and we'll run with it. Here we go.
I've been working in the solar industry for 7 years now. About 3.5 years ago, I started my own company, Intelligent Solar, here in Massachusetts. I do, service areas, mostly central Mass, some southern New Hampshire. We provide full turnkey solar and battery installations for residential and commercial applications. So if you have a need for any of that, give us a call and be happy to provide a quote.
In the past, what systems have you been using?
For the most part, we're doing grid-tied solar with battery backup. Most of what I've been installing is SolarEdge. They are like the market leader in the residential space, and they're slowly creeping up on the market in the commercial space as well. I've definitely used Enphase before if folks were looking for microinverters. And I'm looking at this LionEnergy system as a potential offering as well. It comes in at a good cost point and especially for providing the storage as well. This system's been up and running for about 3 months now. So the company LionEnergy actually sent 2 of their engineers out here to help me install it. I got this as kind of a little bit of a deal to kind of get it in my hands, and I might actually offer it to some of my customers. So they actually came out here, helped me install it, wanted to make sure I knew everything that I needed to know to make for a successful installation. And they were great to work with, and the product's been working pretty good so far. Some of the issues I've been noticing with the LionEnergy system include minor flickering of some of my LED lights, but not all of them. I do hear a little bit of like an oscillating noise in the panel, and LionEnergy has actually determined what's causing that, and that's one of the reasons why we're replacing the inverters. So we're replacing them due to a slight relay issue. It's not keeping the system from working 99% of the time, but is causing these strange abnormalities. So the inverter looks like it was designed to be installed outside with all the gasketing around the face plates and the entrances. But the rest of the enclosure for the battery cabinet and the raceway, the chaseway for the wires, doesn't appear to be water rated.
So we were looking at these and I was asking what these little things are. They're pressure relief because this is all gasketed. So if you did have the right wires and everything was tightened down, then air wouldn't get in there. And I was asking, well, what about the fans? Well, it turns out these are just heat sinks. So it's a separate piece that goes on top and is welded, but that's just heat sinks attached, but it's not, water can't get from this part to this part.
These are currently operating in backup mode only. I have experimented for about a week running off grid and it's been working great. Essentially the solar on the roof, stays on because the battery system behind me provides grid voltage and frequency. So it kind of tricks the Enphase microinverters to stay on, thinking that the grid is alive. We are disconnected from the grid when that happens, so no power gets fed back. and it works great. It works great off-grid, and it has a 16 kilowatt capacity with these two inverters. They're both 8 kilowatt inverters.
What is it?
17 millimeter.
All right. So 17 millimeter on the big positive and negative.
We're going to start taking apart these old inverters to swap them out with the replacements. Well, that was loose.
I saw the same thing on this one. These things were not put in tight at all. they
Wasn't
were
me.
Who put these in?
We'll torque it good when we put them back on. So it took approximately a day to install the batteries in the inverters. Prior to LionEnergy's engineers coming out to assist me with the install, I had wired up the backed up loads panel and moved a bunch of loads over. So I had that done. So I had about a day's of my own time into it prior to them coming. But it was a relatively smooth install. You can AC couple existing solar to it. Meaning if you have an existing solar system, you can tie that into it. If you're doing a new install, you can DC couple solar into it as well. So then it'll be a DC coupled solar and battery system. I currently have 22 SolarWorld 275s on my roof with microinverters, N-phase microinverters, and I am AC coupling those into this battery system. Because it didn't really make sense to take the panels off the roof, take the microinverters off, and then rewire everything to be DC coupled. It's much easier to just AC couple that into the LionEnergy system, or any battery backup system for that matter. If I am to install these inverters and batteries on a new install, I would absolutely do DC coupled. It just makes sense as compared to doing an AC coupled setup. The fact that we can AC couple solar into these inverters is excellent because it provides a great means for folks to retrofit existing solar systems to add this battery system. But absolutely from the get-go, if we're installing this on a new project, we will be DC coupling them. I can AC couple up to 8 kilowatts AC on each inverter, according to LionEnergy. I'm currently AC coupling 5 kilowatts and it's been working out just fine. You can DC couple just over 10 kilowatts of panels per inverter. Yep, per inverter. So you could do about 20 kilowatts on this system.
Could you do both, DC and AC?
You could do both DC and AC coupled. So you could be AC coupling, 16 kilowatts of solar plus DC coupling 20 kilowatts of solar on this 2 inverter setup. If you really wanted to, that would be a lot of solar.
At the top of the battery, we have the main positive, the main negative, and a communication port. So these wires are then traveling through into this wireway, which is directly underneath one of the inverters. This is where it's then tying in to some bus bars, which are those black plastic cover and then that red one over there. They're paralleling this negative and positive, so these two batteries become paralleled and join up with this inverter, and one of them travels over through the T-fuse into this side. And we have the same bus bars in the back. Those bus bars in the back are screwed to the plywood on the back wall. So this switch is paralleling all the communications. We come up, we have the positive and negative for this battery. And these are all your AC inputs and output.
The grid input to this battery. We have the load output to the backed up loads panel. And this is a multi-function input or output port, which can either be generator, it can be AC coupled solar, or it can even be a smart load. So here we have the PV inputs. So if we had DC coupled solar going to this, you have 4 strings that you can connect in, each with 2 MPPTs total, and they're combined here. So these batteries are LFP, or lithium iron phosphate. They are a little heavier than NMC, but my understanding is that they are safer. And they have longer cycle lives. They should last a good 10 years, up to 10,000 cycles. I used 6-gauge wire going to each inverter and a 60 amp breaker for each inverter. So that allows me to pass through 60 amps of current when I'm on grid through the inverters directly to the loads, the backed up loads panel. Here we have 4 batteries. This is an individual battery unit right here. Inside this unit, from about here down, we have all of the individual LFP cells, the lithium iron phosphate cells, that are then connected up top, and they are controlled and protected by the BMS, or the battery management system, which is also in here. Out of the top of this are the connections for those batteries. What I like about this LionEnergy system is they use a nice connector. This is metal, but is insulated on the outside from the connection, from the connector. So this is not live. Otherwise it would short out. But these are really nice connectors, very sturdy, and they're much better than, for an installer, than using nuts and bolts to make the connection. So if you look at these 2 batteries in this inverter, and then those 2 batteries in that inverter, they're technically separate systems. So these 2 batteries are directly connected to this inverter, and then same for over there. And that connection happens through a set of bus bars to connect these 2 batteries together on the DC side. And then they connect into the inverter up top here. The 2 sets of batteries are then also connected to each other to be in parallel, so everything is drawn evenly. But they're connected through a T-fuse. This is a 250 amp T-fuse, just to protect in case there was a fault, that there wouldn't be excess contributed current from these batteries to those, because that could cause an issue. Each battery behind me is just under 14 kilowatt hours. It's like 13.8. So that provides us about 56 kilowatt hours of storage, which is sizable. Depth of discharge, I'm trying to keep it above 20% or above an 80% depth of discharge, so that we leave at least a 20% reserve, because that does extend the battery life. But right now I'm not even really cycling the batteries much, because I'm just running in backup mode. So if the power does go out, the batteries are fully topped off, ready to go. This system is more designed to power a backed up loads panel. Some people call it a critical loads panel, where you have all of the loads that you want backed up in that separate sub panel, instead of going directly from your meter outside before your main panel and having that battery system interconnected there. This system's not so much designed for that application, though it can if you have the right transfer switches. So I decided to do a sub panel and put the loads that I needed in an outage on there. Also, it helps keep the batteries from drawing down too quickly, right? So if you're in an outage, you really shouldn't be using your dryer, right? I mean, you could, but you're going to drain the batteries significantly faster. So to me, it didn't make sense to have the dryer and the larger heating system and oven on there. With this system, absolutely, you could technically run an entire house. You just have to configure the connection a little differently. Here are the mounting brackets for the inverters. We have 6 screws just going into the plywood, but then 2 screws, Tapcons, about 3-inch long, going directly into the concrete behind the wall. So they're not going anywhere.
So we are sitting on the bracket, but this inverter's not sitting all the way down. You can clearly see there's a gap here and a gap here. So we're like, well, do we need to move the mounting bracket down lower? But if we do move the mounting bracket down another 1.5 inches or whatever, we're going to hit this box. So we have a different theory of what happened. Does it work to flip this around?
No, so we tried, and unfortunately the top has 2 holes and the bottom has 3 holes. So when we flip it around, the hole's going in. That doesn't work.
Nope.
So we grabbed the covers off the old inverters and we're gonna put those on.
Let's see if the holes line up this time.
Perfect.
That is so funny. So that means that these 4 holes were put in the I guess the Chinese factory flipped the template maybe when they drilled for these four.
Must be. Crazy.
I don't know. All right, so now at this point, this piece of steel is off the old inverter with the new mounting brackets. And now everything should line up. Looks like we're going to have plenty of space now.
We're looking at my phone, which is connected via local mode, which is essentially acting as the battery's screen or the inverter screen right now. And we can see that the solar, the AC coupled solar, is actually charging the batteries at just over 1400 watts or almost 1500 watts. So right now the solar is powering the house completely and is actually charging the batteries. So what we're going to do now is flip off the solar breaker so that the battery inverters can provide the load to the house, power the loads in the house. Just going to refresh the screen. Now with the solar off, you can see that we're discharging the batteries at 718 watts to power the loads in the house.
Okay, and this is how much the house is using?
Yep, so you can see here how much the house is using.
The house is using 625 watts. And we're using 721, so about 96 watts being consumed by the inverter.
We're going to simulate a grid failure by throwing this 100 amp breaker in 3, 2, 1. So now we're running off grid. And all you saw was a very slight flicker in the lights. The transfer time is actually 5 milliseconds. Fast enough that my clocks don't reset and my compressors don't stop running. You know, if the heat pump water heater is running, they'll just keep on going. It's quick. Yeah, we just finished installing and having another issue. Not entirely sure what's going on, so I'm going to give the company a call. See if it's an issue with the setting or what, but we're getting an alert saying there's an overcurrent on grid A phase. So not sure what's going on there. Honestly, I was hoping that this experience of swapping these out would just fix the problems I had and it was going to work well, but without that, definitely not going to be installing for customers anytime soon. Maybe if I get everything up and running and working smoothly, I might reconsider. But it's a great concept, and the hardware is great, but I think they have some software things they need to work out before the product really is bulletproof. LionEnergy, I don't believe currently sells this direct to consumers. They work directly through the installers. They don't even go through distribution, so they actually sell directly to installers such as myself.
How much does it cost?
The 2 inverters and 4 batteries I have behind me cost approximately $30,000 from LionEnergy, but that doesn't include the installation. That doesn't include the wiring and the backup loads panel or any of that kind of stuff. Hey guys, we're back here in my basement. It was about 3 weeks or so later. Been back and forth with LionEnergy's tech support team about the issues going on with the inverters. Finally got them up and running, but we were having issues with them in parallel, and it seems that it's a firmware issue. So they're working on their firmware. For the time being, I'm keeping them not parallel, so I have just one inverter running. Everything seems to be running just fine. And in the meantime, we'll wait to see if their firmware updates fix the paralleling problem. But I think for the meantime, probably gonna wait a good 6 months or so before they really have a good rock solid product that doesn't have any issues before I offer it to any customers. But it's been fun beta testing this, if you will, for them, and hopefully they can get it to where it needs to be a long-term solution for people.
Kevin, thanks so much for letting me come out and film and look at all of the insides of all these different boxes. I had a great time. Thanks so much.
You're very welcome.
Thank you everybody for checking out the video. If you like it, please like, subscribe, comment, and share.